Right, I welcome you back. And we are going to have more examples about the flowcharts. In this case, I have decided to begin with those examples where we are required to draw a flowchart. But there are those examples where you are the one to draw, rather where the flowchart is drawn for you, and they want you to perform a dry run and state the purpose. So let's first look at these ones. And this is our example 2. They want us to show that the Newton-Raphson formula for finding the fifth root of a number n is given by that fifth root of the number n is given by this. Then thus we construct a flowchart that reads value of n and initial approximation, computes and prints the fifth root of n correct to 3 decimal places, and hence we take n as 50 and x naught as 2 to perform a dry run that reads the root to 3 decimal places. So let's first prove this out. Finding the fifth root of a number n. So I don't know the fifth root. So let me say, let the root of that number n be x, implying that x is equals to the fifth root of n, that is n power 1 over 5. When you power 5 either side, you're going to have x power 5 is equals to n. And when you make, when you form the equation to be x power 5 minus n is equals to 0. So from this, you can have it like f of function of n, f of xn is xn power 5 minus n, and then its derivative is 5xn squared, just that, because n is a constant. So if you substitute xn plus 1 is equals to xn minus f of xn over its derivative for the values of n equal to 0, 1, and others, it means that your xn plus 1 is going to be equal to xn minus the function, which is xn power 5 minus n, divided by its derivative. Derivative is 5xn power 4. This is power 4. So 5xn to the power 4. Now what happens is, you take the LCM here and you multiply it there, so it is going to be 5xn to the power 5 minus xn to the power 4, then plus n, everything over 5xn to the power 4. So when you get 5xn power 5 minus xn power 5, this is a 5 members. It is going to come up as 4xn to the power 5, all right? Then plus n out of 5xn to the power 4. But they wanted that to factorize out 4 over 5, so we can divide either side. Xn power 5 over 5xn to the power 5 plus, yes, to the power 4, sorry, because we divide this by this and this by this, so plus n over 5xn to the power 4. So when you factorize out a 4 out of 5, you're going to be left with xn here plus n out of 4xn to the power 4. And that is our Newton-Raphson formula. So this formula is what we are going to carry on to do other computations as required. So from here, that was part A. They want us to construct a flow chart that reads the value of n and the initial approximation. So how do we do this? We shall start on a flow chart. Shall have start. Then we have not carried any iteration yet. So we shall have that box where our number of iteration is 0, right? Then from here, now we go to the read statement, whereby we say that the read statement is represented by using a parallelogram. So you have to draw a parallelogram and you put what you're reading. And we are reading, they say that we read the value of n and the initial approximation x naught. Then after that, we go to the statement where we put our equation that we have proved, or the equation, any equation that is given. So we shall have xn plus 1 is equals to 4 over 5 over xn, rather into xn plus n over xn, right, over 4, xn to the power 4. Then from here, we go to the decision box, whereby in the decision box, you're asking yourself whether the tolerance you're asking is xn plus 1 minus xn, the magnitude less or equal to. Since they wanted us to record our answer in 3 decimal places, so you'll be having 0.0005, and you put a question mark because it's a question. So if it is a yes, we shall print if it is a yes, you print. And what are we told to print? We are told to print, we are told to print the 5th root of n. So you're printing the 5th root of n, or one can put xn plus 1 because that will be the root. And after printing, of course, you have to end the program. So we have to put stop. So you need to know the shapes we use and the shapes we don't use. Then here, if you find that that is a no, it means that you are going to increase the number of iterations. Okay, we shall increase the number of iterations, and that is where n tends to n plus 1. And when you increase the number of iterations, you'll be getting the new roots. And that's where we shall have our xn tending to xn plus 1. And then after that, we shall come afresh, we substitute. Shall come afresh and we substitute in our formula, and then we do continue. Okay, we shall continue after substituting into our formula. All right, so that is what we are having. That is what we are having. In case there is any question about that flowchart, you guys will ask, you will send some comments and we see, because it is after increasing the number of iterations that you come back and substitute in the formula and you continue, okay? So even when we are performing a dry run, you see the value of xn we get, we substitute it again into the formula, then we continue until that decision box is fulfilled. So after finishing this, we are told to perform a dry run. So that was the B Roman 1. Then we are going to perform a dry run here, and I told you that dry run has gotten the number of iterations, it has gotten the root, it has gotten the real root, then it has also gotten the error magnitude. We want to see if it is less or equal to 0.0005, okay? So when the number of iterations are 0, we shall have our x naught, it was given as 2.0. Then we shall be substituting into this formula. Remember that value of n was given as 50. So you'll be substituting in that formula direct to see what you are going to have. So we are going to have, if you substitute the value of n as 50, you're going to have 2.225. And when you take the error here, by getting xn plus 1 minus this, you get 0.225. So this is still greater than the error that we want. So we shall perform the second iteration. And by the second iteration, this xn plus 1 will be our n. So it will be 2.225. And when you substitute into this formula, the value of n will keep constant as 50. You're going to get 2.188. When you take the error here, when you subtract, you're going to get 0.037, which is still beyond 0.0005. So you perform another iteration where you'll be having this one now as your value of xn. So we shall have 2.188. And when you substitute this into this formula, you'll be having 2.187. And when you take the difference, you're going to have 0.001, which is still greater than 0.000. So we shall perform the third iteration. When we perform the third iteration, still now what was the result of iteration 2 will work as our xn. So we shall have 2.100. Is it 100? 2.187. Sorry, it is 2.187. And when you substitute it here, you're going to still get the same value, 2.187. And when you take the difference, you're going to get 0.000, which shows that this is less than this. So after getting the error as told, that is when you can come and conclude that the root of value of n, which is 50, the fifth root of n, which is 50, so that the fifth root of 50 is 2.187, correct to 3 decimal places. That is how simple it would be. Let me do you another question, and then we see how best we can now work it out. Let's have a look at another example, then we see how we can work it out. Okay, let's see how we can work it out. Let's do another example. So this is example 3. Part A, show that the iterative formula based on Newton, Raphson's method, approximating the root of the equation 2 in x minus x plus 1 is 0 is given by xn plus 1 is equals to xn into 2 in xn minus 1 over xn minus 2 for n is equals to 0, 1, 2, and other values of n. Then part B, they want us to draw a flow chart that one reads the initial approximation of the root two that computes and prints the root correct to 2 decimal places using the formula in A, then part C, checking X not at 3.4, perform a dry run to find the root of the equation. It is 3 marks. This is 5 marks. This is 4, 5, and then 3. So this question is taking 12 marks, and let's see how we can easily fetch these marks. So the proving part of this question is the easiest because it's a matter of us being smart. They have given us the function 2 ln x minus x plus 1. So you just need to know the function given, rather the equation given. Then when it comes to the flow chart, you need to know what are we reading, the initial approximation. What are we printing, the root. So, and how many decimal places we are given? 2 decimal places. So what would be the error? 0.005. And then you go. So we shall say solution for part A. We are given the function of xn. Okay, if xn can be established, first call it function of x as 2 ln x minus x plus 1. Then the derivative, it will be 2 over x because this is 2 times the derivative of ln x, which is 1 over x. So that is 2 over x minus 1. Implying that f of xn, if you bring in the n, everything will be everything where I find x must put subscript n minus xn plus 1, and f prime of xn is going to be 2 over xn, then minus 1. So looking at this, using xn plus 1 is equals to xn minus f of xn divided by the derivative of xn. Okay, it would imply that by substitution, our xn plus 1 is going to be equal to xn minus the function, which is 2 ln xn minus xn plus 1 out of the derivative, which derivative is 2 over xn minus 1. Of course, here, when you work it out, of course, the LCM will be xn, so it will move up and you will be left with 2 minus xn down. Okay, so this one is going to be equal to xn plus 1 as xn, right? Be xn into 2 minus xn, right? Minus xn into 2, then xn minus xn, then plus 1. Everything is over 2 minus xn. One may wonder where this one is coming from. Remember here you have 2 over xn minus 1. So the denominator only, this denominator only can become 2 minus xn over xn. So the xn moves up. Of course, if you multiply into this, it moves up, it will multiply into, that's why you see me saying xn into the whole of this. Then the other 2 minus xn will multiply into this, LCM. So when you expand that, you're going to get 2xn minus xn squared minus 2xn ln xn plus xn squared minus xn, everything divided by 2 minus xn. So when you look at this, minus xn squared plus xn squared will go to xn minus xn, you'll be left with xn. So shall have xn minus 2xn ln xn, everything we divide by 2 minus xn. Now looking at this, we can factorize out xn being common either way. So we shall have xn into 1 minus 2 ln xn. Okay, then everything over 2 minus xn. Okay, so here, if we move out a negative, it will be minus xn, and the this one now will become -1, of course. Of course, when you move out a negative and this is positive, so it will become -1 here. Okay, it will be -1, then this will be 2 plus, so it will be 2 ln xn minus 1 out of, if you move a negative outside here, it will be negative in 2. Now xn will be positive, then 2 will be negative, so -2. Now this negative and negative will cancel, and we shall have our answer as xn plus 1 is equals to xn into 2, then xn minus 1, everything is over xn minus 2. So this is how we come up with the formula that they want us to prove, or that they wanted us to prove. So after proving a formula, now we can go construct a flow chart. We can go and construct a flow chart. Now the flow chart of ours, that is part B, they told us to draw a flow chart. So you must know the first stage is to start, and after starting, we assume we have not carried any iteration. So the second step is where we have our n is equals to 0, no iteration at all. Then our third stage, we are reading something, which something we were told that we read the initial approximation to the root. So we shall say read, but what are you reading? I'm reading x0, the initial root to the initial approximation to the root. Then after that, I'll bring in my formula, which I put in a rectangle, and that formula is xn plus 1 is equals to xn 2 ln xn minus 1. Everything is over xn minus 2. Now, after putting the formula, you go to the decision box. You're asking yourself, after substituting into a formula, is asking yourself whether xn plus 1 minus xn magnitude is less or equal to the error. We are given 2 decimal places, so 0.005, of course, with a question mark. After asking yourself that question, if it is yes, then you print what you are told, and we are told that we shall print the root, which root is xn plus 1, but you must use a parallelogram. So we shall say print, but what are you printing? Xn plus 1. After printing, of course, the machine has got to rest, so you have to stop it. So we have stopped. But if the answer was a no here, if the answer was a no, you would come, of course, you as a master, you must add this step. You come increase the number of iterations. So meaning that n plus 1 will be n, one can say n tends to n plus 1. And as that one takes place, xn will tend to xn plus 1, right? Xn will tend to xn plus 1. And if that is the case, then we shall come back and substitute in our formula, and then we start as we had done. So shall substitute in our formula, and then we continue like that. So that is what we call a flow chart, as very easy as you can see it. Now, after drawing a flow chart, we are needed to perform a dry run. And that is our last part. Let me call it part C. We are taught to perform a dry run. And we say that our dry run must have 4 parts. It must have the part of number of iterations, the root, and the root you are computing. Then the xn plus 1 minus xn magnitude, whether it is less or equal to the error. So that is a question. So we shall be asking ourselves until we get the values that satisfy that condition. So we shall have, when the number of iterations are 0, we're told to use the initial approximator 3.4. And when you use the initial approximator 3.5, you substitute it here. I told you that the best way is to substitute all this one in your calculators, right? Substitute all this in your calculators. And then as you substitute it in your calculators, you can get the value of xn plus 1. So if you substitute 3.4 into this as x, okay, you can get 3.51548. Put in your calculator, you keep solving. So you are going to get, the L after subtracting, you get 0.11548. And my next time I will get a calculator and come with it, and I show you how we put these formulas and we keep solving so that we don't get problems. So still, you can see that this error is bigger than the value you're interested in. So you will take another iteration, whereby this one now we work as our value of xn 3.51, okay, 51548, and when you substitute it, you get 3.51286, and when you take the error, you get 0.00262. Want the error to be less, so we can continue maybe until the values become consistent. So when you substitute, since this error is less than, actually it is less than this, then that is enough. We can conclude from here, that therefore, I'm concluding from here, you can say that hence the root is equal to 3.51. You correct your answer to decimal places. So as simple as that. So I'm going to give you 2 flow charts. I'm going to give you 2 questions where yourselves are going to take yourselves through, and then you see how best you can perform, or you can draw your flow chart and you perform the dry run. Then after you doing these 2 questions, there we shall be good to go and look at what if a flow chart comes when it is drawn. Okay, what if it comes when it is drawn? I'm giving you 2, and the first one is one. determine, that is part A, the iterative formula for finding the fourth root. Of a given number n. B, draw a flow chart that reads n and initial approximations. The initial approximation x naught, computes and prints the fourth root of n, collect to 3 decimal places, perform a dry run for capital N is 150, .10, and x naught 3.200. That is number one. Then our number two, I want you to do this. Number two is as follows. All the this one carries 12 marks. So our number two is show that the iterative formula based on NRM for solving the equation ln x plus x minus 2 is equals to 0 is xn plus 1 is equals to xn 3 minus ln xn over 1 plus xn for n is 0, 1, 2. Then that was part A. Part B, construct a flow chart that Roman 1 reads the initial approximation as R, Roman 2 that computes and prints the root of the equation in A, when the error is less than 1.0 times 10 to the power -4. C, perform a dry run of the flow chart if R is 1.6. So we are told to do this. Now, I request that we all do these questions. Then our next lesson is going to be about when you're given a flow chart, how do you attempt such numbers? Those are normally section A questions, but all these I'm giving you section B questions carrying 12 marks. Okay, good time.